This video will demonstrate the relay functionality which is included with the full release of eSimulate. What I'm going to do is build up a circuit based around a relay, and if we accept the defaults we can see that this relay is a parametric shape which consists of a coil block, 2 single pole switches and 2 double pole switches. What we'll do is we're going to build up the circuit to drive the coil part of the relay, and this will be made up of a 24 volt battery connected through a low resistance resistor, which will then route through a switch. And we need to modify the default maximum supported current and voltage for this switch so that it's not overloaded when we connect it up to the 24 volt battery. And to finish this part of the circuit off, we'll need to drop in some earth points and then route some fibres between each of these components. Now that we've done this, we can move on to routing the remainder of the circuit, which will start with a 12 volt battery. This will be routed through 2 low resistance resistors, which will connect through each of the switches in the relay onto some slightly higher resistance resistors. And we will require 6 of these resistors, and now all we need to do is to drop in some earth points and route some wires between each of these components. And once we have this circuit all wired up, we'll be able to examine the relay in its different states, which are controlled by the switch connected to the coil. I'm just going to space these wires out slightly. And to save some time, I'm going to let RST automatically connect up the output ports from the relay to the input ports on the resistors. Right. And now that we have the circuit all wired up, we can run a simulation with the relay in its non-energized state. And if we examine the current flowing through resistors 8 and 9, we can see that for resistor 8 we're only getting a current of just under 6 nanoamps, which reflects the state of the double pole switch in the relay, and the current flowing through resistor 9 is just under 600 milliamps, which represents the closed state of the double pole switch. Now if we close the switch, this will allow the relay to be energized. If we rerun the simulation, we can see the states on each of the switches within the relay have changed state. And if we examine the currents flowing through resistors 8 and 9 again, we can see that resistor 8 now has just under 600 milliamps, whereas resistor 9 has just under 6 nanoamps. This concludes the demonstration of the relay functionality included with the full release of eSimulate.